Good morning, students. So I hope so that you have gone through the first model and second topic, the types of chemical changes. And in this topic, the very important topic, that's what we are going to discuss, is oxidation, reduction, corrosion, and rancidity. In our day-to-day life, we come across these things in around us. Suppose if you go into a home kitchen, there you'll see that mother is cooking. There, chemical is reacting with oxygen, and you have taken the food inside the stomach. The reaction is there, that reaction with oxygen. We are breathing, no? Oxygen. And at the same time, if you see the some things are which are there around you, iron articles are get rusted. And if you did not take the food for some days, what happens? They will get smell. So today we are discussing the things which are happening in and around us, and those things, if we know better, we can take more precautions and we can improve the quality of our life. So science improves the quality of life. So first, what we are going to discuss, oxidation. Take a copper in a tray, copper powder, which is reddish and brown in color. Now heat it. Then this color will become black after some time. Why? Because the copper turned and it converted into copper oxide. Why like that? Because copper, when reacted with oxygen, it forms copper oxide. So to balance it, I need to put here 2. You can see that copper, what is added to copper? Oxygen is added to copper. So such reactions, we will call it as oxidation reaction. For any element or compound, if oxygen is added, then we will say that that element or compound is oxidized, and that reaction is called oxidation. Now you do the same thing, that black color powder, the black color powder is there, copper oxide. You just pass some hydrogen gas by doing some arrangement, such as in test tube, you take this copper black side and arrange the thing and pass the hydrogen gas. This hydrogen gas, while passing through this copper oxide, the reaction will take place. This copper oxide will react with hydrogen and we will get copper. Now here you can see that what happened for this copper oxide. It has turned to copper. It has lost oxygen molecule. So removal of oxygen is called, that reaction is called reduction reaction. So now so that you understood that what is oxidation and what is reduction. Addition of oxygen is called oxidation. Removal of oxygen is called reduction. Not only addition of oxygen, if we have removed the hydrogen also, that also will be called as oxidation. Now let me recollect the example that we have seen. Second equation, what we have seen, the copper oxide, when it allowed to pass through the hydrogen gas, we got the copper, reddish brown copper back. Here what did you see then? The copper oxide has lost oxygen to copper. So what reaction we will call it as? Reduction. Removal of oxygen is called reduction. Or addition of hydrogen is also called as reduction. Now you can see that here hydrogen, for this what is get added? Oxygen is get added. Therefore, I can call this reaction as oxidation reaction. See, here copper oxide is reduced to copper, hydrogen is oxidized into water. Now both reactions occurred in the same reaction, oxidation as well as reduction. That's why such reactions we will call it as redox reactions. Such reactions we will call it as redox reactions. Okay, now we are going to see some other examples of redox reactions. One example, ZnO plus carbon, zinc oxide plus carbon. Then you can guess what happens. Zinc and carbon monoxide. Here what happens? Guess. Loss of oxygen. Zinc oxide has lost oxygen. Therefore, it is reduced. Carbon gained oxygen. Therefore, carbon is oxidized. So, as both are present in the reaction, then you can call this is also an example for redox reaction. Now, one more example we are going to see where you can find both the things. MnO2 plus HCl gives rise to MnCl2 plus H2O plus chlorine gas. Is it balanced? Totally 4 chlorines are there. I have to put 4, but Mn is balanced. Here 4 hydrogens are there, 2 oxygen. Now it's balanced reaction. Now you can check what happened here. Hydrogen chloride has lost hydrogen. Addition of oxygen or losing of hydrogen is also called as oxidation. So I can call this one as oxidized. Why it is oxidized? Because hydrogen has been lost. So what is oxidation definition now? Addition of oxygen or removal of hydrogen. Now you see here what happened to MnO2. This MnO2 has lost oxygen. So loss of oxygen, what do we call it as? Reduction. As you can see, both oxidation and reduction in the same equation. These two reactions also called as redox reactions. Do you remember in the beginning we have seen the magnesium, when it burned forms the magnesium powder. How it formed the magnesium powder means it reacts with oxygen and formed the magnesium oxide. Now can you guess what happened here? As magnesium is added with oxygen. What type of reaction as oxygen is added to magnesium? Good. It is oxidation reaction. Okay. So so far what we have learned in this topic? We have learned oxidation, we have learned reduction, and we have learned redox reactions. What is oxidation? Addition of oxygen or removal of hydrogen is called oxidation. What is reduction? Removal of oxygen or addition of hydrogen is called oxidation. What is redox reaction? If oxidation and reduction happens in the same chemical reaction, we call that as redox reactions. Okay. Now, next what we are going to see is corrosion and rancidity. Corrosion. Why it happens? Corrosion and rancidity both are examples of oxidation reactions only. If you put the iron particles long time in the water and air, it reacts with water and oxygen in the air and slowly it gets oxidizes and will get spoils. And once it's spoiled, then we cannot use it for anything. So this is the main problem. Iron is very strong and we can use iron for so many things, even construction of bridges, construction of buildings, vehicles and all those things. As iron is very strong, it is helping us many ways. But because of our carelessness, if we put the iron outside or if we make the iron, allowing the iron to water and all those things, those will get spoiled. And not only iron, silver articles, they will become black if you put long time like that. Copper articles, if you will see that some green coating formed over on that. These are all the examples of corrosion. So we need to take care to prevent from the corrosion. One best example is just paint it. The iron articles will be paint. Do you know that why? If we paint it, this paint prevents oxygen and water to come in contact with the iron. So the rusting will not occur. So now you understood why do we paint? To prevent from the corrosion. Now let me see the rancidity. If you keep the food for a long time, for 2 days, 3 days, you will see that some smell comes and taste also not nice. Why the smell and taste changed? Because the food get oxidized and became rancid, means spoiled. So if we keep food for longer time, the oxygen in the air will react with the food chemicals and forms a new compound that is not good for the health and makes the smell change and the taste also will be changed. Now how do we can protect the food from the rancidity? 3 discussions we are going to see. If we make food not to react with oxygen, so by adding some antioxidants, we can prevent the food from rancid. Another one, airtight containers, such that we will not allow the food to come in contact with the air. By keeping in airtight containers, that process of getting spoiled will be delayed or slowed down. And the last, some gas flush with gas such as nitrogen and in airtight packets, air-filled packets. That means the chips packets we are seeing, no? In the chips packet we feel that air will be there. Actually that is not the air, that is completely nitrogen gas. So when nitrogen gas is there, nitrogen does not react with food. As oxygen availability is not there, these food materials will not get spoiled. So these are the 3 methods we can use to keep our food for longer time not to get spoiled. So many other methods are there, because of that the foods get spoiled, no. But the oxygen is also one of the factors that makes the food get spoiled. Now let me see what are the in-text questions are there in this particular topic. So we have learned what topic? Oxidation, reduction, corrosion, rancidity. And even in oxidation and reduction we have seen the redox reaction. Can you recollect what we have done? Oxidation is what? Addition of oxygen or removal of hydrogen. Reduction, removal of oxygen or addition of hydrogen. Redox reaction, in which both the reactions occur in the same chemical reactions, then we call such reactions a redox reaction. Corrosion, iron such as some metals will get spoiled or become waste when they react with oxygen and acids or air and water, so they will get spoiled. The spoiling of the metals, we call it as corrosion. And how do we prevent it? By painting is one of the methods. Rancidity, spoiling of the food because the food reacted with the oxygen. So this is what the content we have learned. I said a method. Whenever you learn a content, a topic I'm saying, learn the topic, understand it, and there you learn the in-text questions of related to the topic, exercise questions, board questions, and some questions from chosen and prepared as a question bank. You just please go through all these questions. By the end of this, you will feel confident in this particular topic. So once you confident, then only you go to the next topic. Why unnecessarily to hurry to read as much as possible? When you read more without keeping everything in mind, what is the use? Is it not? So learn this topic. As you understood this topic, let me see what type of questions we get in the examination. One of the question is given like this. Identify the substance in in-text question that are oxidized. Identify the substances that are oxidized and the substances that are reduced in the following reactions. So we need to identify whether it is oxidized or reduced. You say that what happened for sodium when it reacts with oxygen? What happened? Guess. Sodium is added with oxygen. So addition of oxygen is called oxidation. So what happened to the sodium? Sodium is oxidized. So sodium is oxidized, nothing else. So what is the answer for this question? Sodium is oxidized. Now I am going to see another one. Copper oxide plus hydrogen gas, copper metal, and plus water vapor. Now you see what happened. Copper oxide lost its oxygen. So as lost its oxygen, what happened here? It is reduced. So you need to write copper oxide is reduced to copper. Now you can see that hydrogen is getting added with oxygen and formed as a water. So what happened to hydrogen? Hydrogen is oxidized to water. So what are the 2 points you have to write? Copper oxide is reduced to copper. Hydrogen is oxidized to water. This is the in-text question. Only one in-text question is there related to this topic. Now let us see the exercise questions. Explaining the following terms of gain or loss of oxygen with 2 examples each. Oxidation and reduction. What is oxidation? It's there on the board now. Addition of oxygen is called oxidation. So many examples you can give. Magnesium plus oxygen gives rise to magnesium oxide. Copper plus oxygen gives rise to copper oxide. So both are the examples. Reduction, we know that removal of oxygen is called reduction. You can see this is the example of reduction. Here copper oxide is reduced to copper, and you can give that iron oxide plus aluminium gives aluminum oxide plus iron. This is also the good example for the reduction. Now another question is there, exercise question. A shiny brown colored element X on heating in air becomes black in color. Name the element X and black colored compound form. Always they frame the questions from the textbook content only. Recollect that at the beginning of this video, I explained one experiment. When copper is burned, then it turned to black color copper oxide. Now recollect that experiment. Now you can easily understand what is that X in the question? Copper. What happened here? Copper is oxidized to copper oxide. Can you recollect the formula? Copper Cu plus O2 gives rise to CuO. Balance it afterwards. Okay. Now another question, in-text question. Why do we apply the paint on iron articles? Why? We know that to prevent from the corrosion, but we explain in detail. And fourth question, exercise question. Oil and fat containing food items are flushed with nitrogen gas. Why? So here, while writing the answer, you just explain what happens if nitrogen is not there. If nitrogen is not there, food materials will combine with oxygen and they will get spoiled and they become rancid. Taste and smell changes. It is not good to take the food. Now, if we fill with the hydrogen, the food is not get allowed to react with the oxygen. So the food will not become rancid and food materials stays for the longer times and we can preserve for the longer times. That's why unreactive nitrogen gas we use to flush to preserve the food materials. And another exercise question is given. Explain the following terms with one example each: corrosion and rancidity. Corrosion, what did we see? Metals, when they react with acids, water, air, they get spoiled and they lose their nature and they become waste. That phenomenon is called corrosion. Rancidity, the above example only we have seen. Rancidity means what happens? When food is reacted with oxygen, they get spoiled and their taste and smell changes. Okay, these are the exercise questions. Now, board questions, I didn't find much board questions, but this time we get the board questions. But remember, in-text questions, exercise questions have given sufficient grip over this content. So, whatever the topic I have explained with the in-text and exercise questions and some question bank related to the topic I have given just below the link. You just press the link below and please get the material and go through the material. And please students, please work on this. Get grip over this particular topic. Okay? And once you've done this, I will say that you can write any answer which it comes from this question. So far we have learned 3 more topics, topic 1, topic 2, topic 3. In first topic what we have seen balancing the chemical equations. And in second topic what we have seen, types of chemical changes. And third topic what we have seen, oxidation reduction and corrosion and rancidity. And under every topic I have given the link. That from that link you can get the material, content explanation, in-text exercise question, board questions and some question bank questions. Please go through all the 3 videos. I hope so that you will understand the chapter perfectly and